Okay, so tenacious test 1, question 2. Over here we have a quadratic number pattern, and the first question is for us to find the general formula, Tn, and then the second question to find the highest value for this sequence. Okay, so let's get into it. A quadratic number pattern has a constant second difference. Basically what that means is that not these first differences will be constant. As you can see, the difference here is 9, then the difference here, I lie, sorry, this is 11. The difference here is 9, and the difference here is 7. One easy way to work out these differences is simply to take the just to take one of the terms and minus it by the previous term. So I'll take the negative 5 and I'll minus that from negative 16, and that's how I get the 11. In the same way I got this as well. I just said 11 minus 4 and I got the 7. Okay, easy peasy. To work out these second differences, we can now clearly see that this is simply just 2. Okay, the differences there from 11 and 9 and 9 and 7, those are just 2. Okay, so we are going to be using these formulas that we've established previously to solve the general formula, because just keep in mind your general formula looks like this, as it is a quadratic pattern. Okay, so that's a general formula, and to work out A, B, and C, we'll be using these formulas over here. I have shown in a previous video where these formulas come from. They're not random at all. They actually come basically from this, I guess, but yeah. So they're not random at all. Actually have some meaning. Let's start with the first one, because this equation only has one variable and we can solve equations that have one variable. 2a equal to 2, a is just equal to 1. Let's substitute that in here. So if a is equal to 1 and 3a plus b is equal to 11, 3 multiplied by the 1 is just 3. So if you take the 3 across, you minus it from the 11, and that is just equal to 8. So we have 1, we have 8, we need to work out c. So since a is 1 and b is 8, and a plus b plus c is equal to negative 16, I guess we take these two terms across, so that's 9 together. If you take it across, you minus it from the negative 16, and you end up with negative 25. So I'll just go ahead and substitute that into this formula. So 1a, I'll just say, sorry, a is equal to 1, so I'll just say 1n squared, invisible 1, plus 8n minus 25, like that. Okay, so just to test if this formula works, I'm going to go ahead and substitute into my calculator 1 to see if I get this term. I'll substitute 2 to see if I get the second term, and I'll substitute 3 for this and 4 for that. If it works for all 4, then I'll trust this formula. Okay. So I went and double checked my answers with the calculator. You can actually see I'm making use of a table here, and my x's doesn't correspond with my y's. In other words, the number of my term doesn't correspond with the value of the term. So I get the first one, I get the second one, but I don't get the third and the fourth, which obviously means that my formula is wrong. So I went to have a look at this again, and I missed a key ingredient here when I was working out my second differences. So I can't just go ahead and say, because the difference between 11 and 9 is 2, I'll just write it like that. I need to understand the direction that we're going in. And to go from 11 to 9, you're actually going backwards. You are minusing, right? So that's why I need to include a negative there. That is so important, and that basically ruined all our calculations. So I'll just go ahead and fix that. Since 2a is equal to negative 2, a would then be equal to negative 1, right? So I need to fix this up here as well. This is 3 multiplied by negative 1, which is now negative 3. And once you take negative 3 across, you need to add it to the 11, not subtract it like we did here. And this gives us an answer of 14. Okay, and so now a is negative 1 and b is 14. So I'll just put that in here. Negative 1 and 14. Now, if we add this, that gives us 13. If I take 13 across, I need to now minus that from the negative 16, and that gives me negative 29. I'm being very careful not to make another mistake, but that is negative 29. And I'm going to check this one again. Okay, and it actually checks out. So now my x's does correspond with my y's. If you go to the top here, you can see 1 corresponds with the negative 16. Then the second one is negative 5. The third one is 4. The fourth one is 11. That all matches these numbers. If you want to know what I'm doing in my calculator, I'm actually making use of the function. Okay, so I go in mode setup and I click on table. And then, oops, I erased it all. But I basically punched in the function. I swapped out the n's for x's just because your calculator makes use of fx instead of tn. And this was negative 1. This was a 14 and not an 8. And this was 25. Sorry, 29. It was 25, but we calculated correctly as negative 29. Okay. So that's your formula. That's the quadratic formula. And as you guys can now see how easy it is to make a mistake with these calculations, please be careful when you are doing this on your own. Right. The next question was for us to work out the highest term in the sequence. So let's have a look at what's happening here. First of all, we start at negative 16, it's a low number, but then we add 11, so it's getting bigger now, goes to negative 5. And then we add 9, it gets even bigger, it goes now to the positive integers, and we have 4. We add 7, we get 11. But notice, each time we are adding, we're adding less and less. So first 11, 9, then 7. And if we continue adding, we'll be adding lesser and lesser values. We'll be adding, first of all, 5, then 3, then 1, and then negative 1. In fact, that is no longer making the values go up. Instead, that is making the values go down. Okay. And so because the values are decreasing now, we can conclude that there'll be a maximum term, because the values first starts going up, 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 and eventually it comes down, down, down. Okay, so it kind of makes this shape. I'll just draw it over here. Kind of makes that shape, right? This is the parabola that we are well familiar with, the parabola function. So it goes all the way up, and at a certain point we reach a maximum. And after that maximum value, it goes back down and we get terms that are less and less and less and probably negative again like it started out. Okay, so the question is, what is this maximum term? Like, which term has the maximum value? And I guess to answer this, since the maximum value, as you can see, is our turning point, we can make use of a turning point formula. So, if you recall functions, back in grade 11, we made use of this formula. In fact, that was an x, but we'll use an n for now, since we're not dealing with functions, but rather patterns. And this should be a very familiar formula. X is equal to negative b over 2a, except we swapped out our x for an n to find out the term that has the maximum value. And we just substitute our values here. So b is the 14 and a is the negative 1. Okay, you basically work this out. 14 divided by 2, the negatives cancels out, and that's equal to 7. So it's basically the 7th term. Okay, the 7th term. will have the maximum value. And you can actually check that out. If you were to go ahead and add 5 to get 16, you then have to add 3 to get 19, you'd add 1 to get 20, and this is the 7th term, and notice this is the maximum term. Because after you add 1, you're then going to add -1, right? That's the next one that comes in this pattern, -1. So that just goes back to 19. And then you add -3, and that goes back to 16. And notice you're just going backwards all the way. So it has that same symmetry that a parabola has. After the turning point, notice it goes up, 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 but when it reaches that maximum, it just goes down again. So you can compare this quadratic sequence to a quadratic function, which is a parabola. And there you go.